Today we are solving a very interesting problem, and it's called single number problem. So in this problem we are given an array of integers nums, and we want to return back an element from the array which don't appear twice. So for instance, in example 1, the element 2 repeats twice but 1 does not, and that's what the output is. Similarly, in example 2, you can see 1 repeats twice, 2 repeats twice, but 4 does not. It only has one occurrence, and that's what we're returning. So the problem is simple enough, but the constraint is that you must implement a solution with linear runtime complexity and use only a constant extra space. Now, if this constraint was not there, then what we could have done was initialize a dictionary of some sort and then have a counter to count the number of elements of unique elements basically, and then find the element that has only one occurrence and then return that element. But because of the linear runtime complexity and a very constant extra space, we cannot do it in that way. So in this problem, I'm going to look at the hint that might give us head us into the right direction. The hint is that think about XOR and its properties. So I've listed some of the XOR properties that might help. There are 4 different properties. You can see if X is some element or number, and if we perform XOR operation indicated by this particular symbol, if we perform XOR between X and X, which is identical numbers, then we get 0. And if we perform XOR with 0 with any number, then we get the same number. If you look at example 1, you can see that if you perform XOR between 2 and 2, it should be 0. And if you perform XOR between 0 and 1, we should get 1, which is the output. And if you look at the solution to your right, we have done exactly that. We performed XOR with each and every element. First of all, I have assigned answer to be 0, initialize answer to be 0, and I have a loop that iterates to each one of the elements in the array, and one by one I'm performing XOR operation and assigning back to answer, and finally after performing all the XOR, I'm returning back the answer itself. Now if you look at example number 2, what we're doing is performing XOR between 4 and 1, which would give you another output. You can see the property number 3 that if we perform XOR between 2 different numbers, we are going to get a different number altogether, which is not good. But there is a fourth property, which is a communicative property that states that if we can perform XOR in any order we like. It's a communicative property, which means that in example number 2, if we arrange these elements such that we have 1 and 1, if we order this, like if we order this array to be 1 and 1, 2 and 2, and finally we have 4. So if we perform XOR between 1 and 1, that is 0. 0 XOR 2 is going to be 2 itself from the second property, and 2 XOR 2 is again going to be 0, and then 0 XOR 4 is going to be 4, and that is the output. But the thing is, we have a communicative property. That means it doesn't matter which order we perform XOR, we are going to give the same result, and therefore performing XOR doesn't, like, the order doesn't matter in this case. So that's why this solution works, and if we run this solution, we should get the output. And also keep in mind that the solution has a linear runtime complexity, because we are looping through the array only once, and it also consumes constant extra space because we are only initializing this extra variable here. So yeah, it satisfies both of those constraints. So we submit it, then that's the solution.